Hi everybody, happy Friday. So today you are going to be learning about solubility curves. So yesterday we learned about what solubility is, how much solute can be dissolved in a solvent. So today we're going to be looking at some graphical representations of solubility through the use of solubility curves. So what this tells us is exactly how much solute can be dissolved in 100 grams of water at specific temperatures. So on our x-axis here we have temperature in degrees Celsius, and on our y-axis we have solute per 100 grams of water. So this is specifically talking about a 100 grams of water scenario. As we're going through, we'll talk about what happens if you don't have 100 grams of water. And on this particular curve we have various different solutes that can be used. So what this graph is telling us is exactly what state these different solutes would be in given how much solute you've dissolved and given what temperature. So yesterday we learned what unsaturated, saturated, and supersaturated were. So an unsaturated solution is a solution that can hold more solute. A saturated solution is a solution that is full of solute, it can't hold any more. And a supersaturated solution is a solution that has more than what it can hold, it's being forced to hold more. So how we're going to read this graph is, if at any given point it falls underneath a solute line, that is going to be unsaturated. So if it's below the line, that is going to be unsaturated. If it is on the line, that is going to be saturated. And if it is above the line, that is going to be supersaturated. So for example, if I'm looking specifically at sodium nitrate here, so this line right here, and let's say I have a solution of sodium nitrate at 30 degrees Celsius, and let's say I've dissolved 70 grams of solute at 30 degrees Celsius. So my point would fall right about here. Now since my point is below my sodium nitrate line, that solution of 70 grams of sodium nitrate dissolved in 100 grams of water at 30 degrees Celsius would be unsaturated. Now, if I had at 30 degrees Celsius dissolved around 100 grams of solute, that would be a saturated solution. So at 30 degrees Celsius, at 100 grams of sodium nitrate in 100 grams of water, that would be saturated. Now if I had forced my solution to hold 130 grams of solute at 30 degrees Celsius in 100 grams of water, that would be supersaturated. So you're looking at where your point is relative to your line, and you can do that for any of the lines on this graph. So going back to what we had started talking about yesterday, as the temperature increases for most of these solutions, we can kind of see this trend going upwards for almost all of these lines. So take a minute and think, why do we see this upward trend in most of these lines on this graph? So if you remember our discussion yesterday, we talked about how as temperature increases, the solubility increases. So when we're looking at our graph here, temperature is increasing as we're moving to the right. So as we're moving to the right, a lot of these lines are moving up. So a majority of these are increasing in solubility as we increase in temperature, like we talked about. Now there are a couple of exceptions on this line. There is NH3 and there is SO2, I would say, are the most prominent exceptions for a downward trend. So NH3 and SO2. Take a minute now and think about why those might be having a downward trend while the rest of them are having an upward trend. You may have noticed that these two compounds are covalent, while the rest of these are actually ionic. They're metal-nonmetal combinations, where these ones are covalent nonmetal-nonmetal combinations. Now, a little flashback to Unit 2. Covalent compounds can be at any state at room temperature. So where our ionic compounds are solids at room temperature. Now, there would be no way for you to know this at this point, but NH3 and SO2 are actually gases. And if you remember our notes from yesterday, we actually said that as temperature increases for gases, the solubility actually decreases, meaning the higher the temperature, the less solute the solvent can hold of a gas. But as the temperature increases for a solid, the more solute it can hold. So that's why we're seeing some of these lines going up and some of these lines going down. The ones going up are solids, and we know that as temperature increases, solubility increases for solids. And the lines that are going down are representing gases, which as temperature increases, solubility decreases for gases. So given what we've just learned about saturated, supersaturated, and unsaturated, and where they are relative to the line, I want you to pause the video right now, go to your notes on your own, on Notability, and try to answer these 6 examples. So at 10 degrees Celsius, so here's 10 degrees Celsius, and 70 grams of solute and 100 grams of water. Remember, all of this is 100 grams of water. So 70 grams of solute at 10 degrees Celsius. What state are the following compounds? So pause the video, flip to Notability, try to answer these, and then come back and check when you're done. So these should have been the answers that you got. So if we're looking at potassium iodide, so this is where our point is. So 10 degrees Celsius, 70 grams of solute is our point. So if we're looking at Ki, potassium iodide, since that point is below this line, that would be unsaturated. Our sodium nitrate line is right here. Again, the point is below, so it is unsaturated. NH3, our line is right here. Since the dot is on the line, that would be saturated. HCl, below the line, unsaturated. Ammonium chloride, NH4Cl, above the line would be supersaturated. NaCl, above the line, would again be supersaturated. So what this is telling you is if you dissolved 70 grams of solute in 100 grams of water at 10 degrees Celsius, these would be the states of these different solutes given those conditions. So now that we know how to read the graph, we can essentially answer a bunch of different questions about it with different solutes, different conditions, different things like this. So, which solute is saturated at 90 degrees Celsius with 40 grams of solute? So the first thing we need to do would be to find that point. So 90 degrees Celsius and 40 grams of solute. So that point meets right about there. So which solute is saturated? So we have to ask ourselves, all right, when it's saturated, what does that mean? Is it above the line, on the line, or below? Well, saturated solutions are on the line. So I need to ask myself, which solute is on the line? Well, that would be NaCl. So sodium chloride is saturated at 90 degrees Celsius with 40 grams of solute. For the next question, it's asking, at what temperature range is potassium nitrate supersaturated at 65 grams of solute? So the first thing we need to do here is find potassium nitrate. So that'd be KNO3. So that is this line right here. And it's saying at what temperature range, so we're looking at a range of temperatures, is supersaturated at 65 grams of solute. So 65 grams of solute looks like it would be right about here, so between 70 and 65. And it's saying supersaturated. So again, is that above, on, or below the line? That would be above. So what temperature range is potassium nitrate supersaturated with 65 grams of solute? So the 65 grams of solute line looks like it's reaching from about 40 to 0 degrees Celsius. And how I figured that out is this is the portion of 65 grams of solute that is above this potassium nitrate line. So since that is above the line, and that is what supersaturated means, my temperature range would be about 0 degrees Celsius to 40 degrees Celsius. So this graph can be a little hard to read. If you thought it was right about 38 or 39, 41, 42, that's fine, as long as, you're close to that 40 number in this case. So now we've got some questions asking us about supersaturated solutions again. So looking at the first one, how much would you have to cool a solution of potassium chlorate with 30 grams of solute at 90 degrees Celsius to make it supersaturated? All right, so we kind of need to break this down, piece it together to see what we're being asked. So a solution of potassium chlorate, so I'm going to find that line first. So that's KClO3. So this is the line I'm talking about. With 30 grams of solute at 90 degrees Celsius. So 90 degrees Celsius, 30 grams of solute. I'm right about here. And what it's asking me is how much would I have to cool the solution to make it supersaturated? So remember, supersaturated means it is above the line. So like we did in the lab yesterday, we were actually able to make a supersaturated solution. So we heated it up to dissolve a bunch of solute in it, because at higher temperatures you can dissolve more, and then we cooled it. And as we can see looking at this graph, as the temperatures are getting lower, the water can hold less solute. But like we did yesterday, if that solute's already dissolved and you're cooling it, you're forcing it to hold more. So you have to actually create a supersaturated solution. All right. So what we're being asked here is, how much would you have to cool it to make it supersaturated, which we know is above the line. So when I'm looking at my point currently, I want to see at 30 grams of solute how much I would have to cool it in order to make it above the line. So I'd be moving across 30 grams of solute here until I get above that line. So to me, that looks like it's hitting right around 60 degrees Celsius. So again, as long as you're around there, it's fine. It's a little hard to read these graphs, I understand. So we're currently at 90. We need to move to 60. So you'd need to cool it about 30 degrees Celsius in order to make it supersaturated. So for the next one, now it's asking, if cooled further to 10 degrees Celsius, how many grams of solute would precipitate out if agitated? So again, this is referring to what we learned yesterday. So you were able to heat the solution with dissolved solute in it so it could fit a lot. And then as you cooled it, again, a colder solution can hold less, but you'd already dissolved it, so it was holding more than it could. And then either if you bumped the test tube or when you dropped that additional crystal into it, you agitated that solution and you caused all those crystals to form and you caused it to precipitate out. And like we talked about yesterday, once that precipitates out, your solution is saturated. So it essentially pushes out everything it can't hold and keeps what it can hold. So it becomes full. So it goes from overfull to full. So now going back to our question here. So it's saying if cooled further to 10 degrees Celsius. So that's where we ended, right at that supersaturated point. So it's saying if we cooled it further to 10. So like yesterday, if you left it in that ice bath for a really long time or something like that, cooled it down to 10 degrees Celsius. So now we agitate it. So when we agitate it, it becomes saturated. And we know that if something is saturated, it is on the line. So right now we're above the line because we're supersaturated. So if we agitated, it would fall to be on the line. So what our question is asking us is how many grams of solute would precipitate out? So essentially how much solute would get pushed out after you agitated it? Well, we had 30 grams. Remember, that's what we initially had. And now that we're on the line, it looks like we're somewhere around 5. Again, give your best estimate. So we had 30. And then we ended up at 5 because that's where it's saturated, that's where it's full, that's where it's on the line. So we would take the difference then. So we had 30, we ended up with 5, so 25 grams must have precipitated out. So if you were to actually do this, 25 grams of crystals would come out after you agitated it. All right, so let's try some other ones. So how many grams of sulfur dioxide would you add to make a saturated solution at 40 degrees Celsius? So how many grams of sulfur dioxide? So let's find our sulfur dioxide line here. That's going to be SO2. How many grams of sulfur dioxide would you need to add to make a saturated solution at 40 degrees Celsius? So now let's say you just want to make a saturated solution. So you want to know how many grams of solute you need to add. So we're doing it at 40 degrees Celsius. And if we want to make it saturated, it needs to be on the line. So when we're on the line for grams of solute, it looks like we're right at about 6 grams or so, maybe 5. Again, do your best estimate. So we would need to add about 5 grams to make that saturated. So now for the next one, if you dissolved 30 grams of ammonium chloride at 70 degrees Celsius, how much more would you need to make it saturated? So we've got ammonium chloride, so let's find that line here. Ammonium is a polyatomic ion, NH4Cl. If you dissolved 30 grams of it, so we're at 30 grams, at 70 degrees Celsius, how much more would you need to make it saturated? So we're currently at about this point right here. So since we are below the line, we are currently unsaturated. So it's asking us how much more would you need to make it saturated. So we're currently unsaturated, we're not full, and we want to make it full. So again, remember, saturated means it's on the line. So we essentially want to figure out how much more we would need to add to get to be on the line at this point. So we're currently at 30. Where do we need to get on the line? So on the line to me looks at about right here, which is right about at 60 grams. So we're currently at 30. We need to add 60. So we would need to add about 30 more grams to get saturated. Because our 30 grams of initial plus adding 30 more grams would just get us to 60 grams. And the reason we want 60 grams is because that's when we're right on the line, and on the line means we're saturated. So a couple more before you are going to try some on your own. So how many grams of KCl would you add to 115 grams of water to make a saturated solution at 15 degrees Celsius? So now we're running into the issue of 115 grams of water. Because remember, this solubility curve is always in terms of 100 grams of water. So what do we do if we don't have 100 grams of water? Well, we're going to set up a proportion. So what it's asking us is, how many grams of KCl would you add? So KCl, that is our line right here. Would you add to make a saturated solution, so that is on the line, at 15 degrees Celsius. So right about here. So this is what we're going to do. I can figure out on my graph how many grams of solute I would need to add to make 100 grams of water saturated. With that being said, if I'm going on the line here, that would be right at about here. So with 30 grams, oops, just kidding. With 30 grams in 100 grams of water, that would be saturated. I know that. So this is KCl, the solute, and H2O, the water. So I can figure out how much water or how much KCl I would add to 100 grams of water to make it saturated at 15 degrees Celsius, but I want 115 grams of water. So what I'm going to do here is I'm going to put an X on the top and put 115 grams of H2O on the bottom. So what I did here is I set up a proportion. So this part of the problem right here is what I got from the graph. So I know that I can dissolve 30 grams of potassium chloride at 15 degrees Celsius in 100 grams of water to make a saturated solution. So this was my graph value. Now over here, this is what I actually want to figure out, because remember, I wanted to figure out with 115 grams of water, how much I would need to add. So this is what my x is representing. I don't know how much I need to add. So we can go ahead, depending on how you've learned how to solve proportion problems in the past. I kind of like the crisscross method. I think some of you call it the bow tie method. Whatever works best for you. So I'm going to continue my work over here. So what I did was I kind of just crisscrossed. So I'm going to take 30 and multiply that by 115, and that's going to be equal to 100 times my x value. So remember, this is what I want to figure out here, how many grams in 115 grams of water. So I'd multiply those together, divide by 100 on both sides, and what that's going to get me equal to is about 34.5 grams of KCl. So I could dissolve, if I dissolved 34.5 grams of KCl in 115 grams of water at 15 degrees Celsius, I would make a saturated solution. Now, of course, what do we always have to worry about when we do a calculation? Sig figs, I know, but it gets kind of nice when we're using the graph here, because this is what we're going to do. We are going to assume that all of these values that we get from the graph are exact. So what I mean by that is we can dissolve, it's exactly 30 grams of KCl in 100 grams of water. So any value we get from the graph, we're going to say is exact. That's been figured out. It's exact, just to make our lives a little bit easier. So when we're coming down here then, really the only measured value then would be this 115 grams of water, because we'd actually be measuring out 115 grams of water in a real case scenario. So this has 1, 2, 3 sig figs, 1, 2, 3 sig figs. Good, done. Final answer. Now a way you can check this. So we would need to dissolve more KCl in 115 grams of water than we did in 100 grams of water, which makes sense. If we have more water, we're going to need to add more solute in order to make that saturated. So you can always reason your way when double checking your work as well. All right, so now the last one. If you wanted to make a saturated solution of NH3 with 40 grams of solute at 60 degrees Celsius, how much water would be needed? So now this one's kind of flipped. Now I want to know how much water I want to add with this particular amount of solute. We're going to use the same method that we did for the last problem. So I need to figure out at 60 degrees Celsius how many grams of solute I could add in 100 grams of water. So remember, our graph is always talking about 100 grams of water. So if I'm looking at NH3 here and 60 degrees Celsius, I need to figure out when that is saturated. Remember, saturated means it's on the line. So at 60 degrees Celsius with NH3, it looks like I'm on the line right about here. Kind of looks like about 22 to me. So what I just figured out is I know if I add 22 grams of NH3 in 100 grams of water at 60 degrees Celsius, I make a saturated solution. But the problem is I want to know if I add 40 grams of NH3, getting this for my problem here, how many grams of water would I need? So again, just like last time, these are my values from the graph. So I know if I had 22 grams of NH3 at 60 degrees Celsius in 100 grams of water, that I make a saturated solution, because that was on the line over here. But I want to add 40 grams of NH3 to an unknown amount of water. So we're going to use the same method as last time. Go ahead and do the crisscross. So I can take 40 multiplied by 100, and that's going to be equal to 22 multiplied by x. Again, that is our unknown. So now we just need to solve for x. So we'll divide by 22. on both sides, and after we do the math, we're going to get about 181.18 equal to x. So what I just figured out is I would need about 181 grams of water to dissolve 40 grams of NH3 to make a saturated solution at 60 degrees Celsius. But what do we always got to do? Sig figs. So remember, these values from the graph we're considering to be exact. We got them from the graph. They've been calculated previously. They're good to go. So what we're going to look at is our given. So 40 has only one sig fig. Trailing 0 is not significant. So if I want 181 to have one sig fig, shave off, round up. I need to keep the value of 100, so that's going to become 200 grams of water. Which makes sense. If I want to add more solute to make a saturated solution, I'm going to need more water. So now what I would like you to do is I want you to try all of these on your own. So I want you to pause the video once I'm done talking here. I want you to go try these on your own. If somebody else is done watching the video up until this point, you can start working together quietly at a lab station. So do this, and then once you've had a chance to try it, I want you to come back to the video, push play. I'll have a really quick explanation, and then I'll have the answers for you. So if you want those in-depth explanations again, go back to those previous problems to see how those were done. These are going to be similar ones. So after you've tried them, come back to the video, quick push play, see what you got right, quick explanation, and do this till the end of the slides. So now is the time to pause and try and come back. So on the graph, I have the line that you're supposed to look at and these 4 points written out with their different values. Unsaturated below the line, above the line, on the line. So for this one, you are looking at the HCl line. The first point I have here is your initial conditions, 50 grams of solute at 30 degrees Celsius. And that would be unsaturated because it's below the line. And I was asking how many more grams would you need to add to make it saturated. So remember, saturated would be on this line. So at 30 degrees Celsius, to get on the line, you would need to add about 15 grams more of solute to get on that line. So that your answer would be around 18 grams. So for this one, you are making a supersaturated solution. So your initial conditions are unsaturated because you're at 40 degrees Celsius at 90 grams of solute and you're below the line. So you're unsaturated and you're cooling your solution. So going left on your x-axis until you're above the line, making it supersaturated. So this is what we did in the lab yesterday. So now it's saying, now it's cooled. Now you agitate it, you do something, and how much are you going to precipitate out? Remember when that's precipitating out that it becomes saturated. It goes from overfull to full, and saturated is on the line. So when we're moving from this initial 90 degrees to on the line, that's about 80 grams. So 90 grams to 80 grams, that difference would be about 10. So your answer would be about 10 grams would precipitate out if you agitated your supersaturated solution to saturated. So for this last one, if you wanted to make a saturated solution, remember on the line, KNO3 with 50 grams of water at 60 degrees Celsius, how much solute would you need? So this is one of the ones where you have to set up the proportion because remember our graph is always in terms of 100 grams of water. So from the graph, I got these values. So I know at 60 degrees Celsius, to get on the line, I need about 118 grams of solute to get on the line here in 100 grams of water. So these were from my graph. Now over here is the given scenario I want. So I want 50 grams of water. How many grams of solute would I need? So I did the crisscross method. So after you calculate your x, how many grams you need, you get 59. We need 1 sig fig. Remember, we're not going to look at our graph values for sig figs. We're just going to look at our given, which would be 50. 1 sig fig here, so you need 1 sig fig here. So 60 grams of potassium nitrate, which, thinking about it, makes sense. This is about 120 grams of potassium nitrate and 100 grams of water to make that saturated solution. Well, if I'm halving my amount of water, I should be halving the amount of solute that I put in. So that's where we're getting that 60 grams of potassium nitrate from. Hopefully this helped and this makes some sense. You can always look at assignment 6.2 to get more practice with this. When you guys come back on Monday, we're going to be doing a lab with solubility curves. So if this is still feeling a little fuzzy after this video, we'll have some time to look at the lab and to talk about this then as well. Hope you've all had a good Friday. Have a really happy weekend. I look forward to seeing you all on Monday.